record this session as well. Okay. Okay. I find the problem here, instead of this bracket, I should substitute the brackets instead of the parentheses. So when you substitute these terms, it will be done. So we can again open the loop. Okay, as you can see, the program was run and it was repeated 400 times. Now, if everything was correct, we can see the response. What happens to my laptop? So let's plot response. To plot the response, you can easily only use the command plot R, because the R is a matrix with two columns. The first column is time and the second column is the response. So if you use the plot R, easily the Maple will plot the second column as a function of the first column. This is the response. Of course, I think we made a mistake somewhere. It must be the response till it's 20. So why response is plotted in this interval? I don't know. I think we should use another command here, because as you can see here, the Maple do not simplify this term, so we need to use another command. Here I use eval f is another command to simplify this code. Again, I will run it. As you can see here, the last point, the response in the last time, it's like this, but if we simplify this, it's a simple response. So now we can plot again, use the plot. Oh, why? I don't know why. It's not from. Guess my laptop is playing up. Oh, now the response is correct. Okay, so as you can see, this is the response for this system. Now, if you change the non-homogeneous term in equation 1, I mean here in this equation, if instead this 100, for example, if we had sine t, okay, for example, if we had a harmonic excitation, here instead of this 100, we had sine t. So in each step, you need to calculate this time t when you want to here for fx. So only you need in the loop, of course, I think I use the time here. Yes, here you can use this command and then you can use the t naught. I mean here instead of 100, for example, I had sine t, and then you can repeat the same procedure. Okay, so this is the total procedure that we need. Let me save this and I will upload it on Moodle if you need it. I don't know why my laptop is hanged. Okay, new numerical method, for example. I will upload this on Moodle as well. Okay, any question? Is it clear?
So question.
Yes, yeah.
So like for our assignment, how do we find the step function?
The step function, let me go to
So the
assignment.
height.
Let me first open the assignment because I don't know what is the question. My does not work. Okay. For which question do you have problem? Question 1 or 2? Can you hear me?
Oh, so sorry. So what I mean is like for Ranchkota method, you need to
The
use
part
height.
B for question 1? Yeah?
Yes, sir. Yes,
Okay.
sir.
Here we want to obtain the response by using the Range-Kutta. We have the equation of motion. This is the equation of motion mx double dot plus 6 dot plus kx. The equation is exactly similar to the one that I solved for you. But here we have ft. As I told you, this is a function of time. But this ft, in fact, is you have the value for ft at each second. You need to find the equation for ft. For this purpose, in the part A, you need to find the Fourier transform. So you can easily find the Fourier transform for this equation. For example, here you need to consider 10 terms, but for part B, for each step, when you want to calculate the response, as you can see, let me use this. For example, at t is equal to 0, here f is 0. Okay, but at t is equal to h, t is equal to h, you need to find this value for f. This is a constant value, but you need to substitute into the, for example, in your Fourier transform equation, or you can use the define this ft in your code. But my suggestion is to define ft as a harmonics by using the Fourier transform, and then you will find a term in here. Let me, for example, let me clear here. You will find an equation for ft. In this code, instead of this 100, you need to substitute ft. For this purpose, before this, you can open a line and here define an ft. And this ft here, you should use the definition of the Fourier transform, because this f, again, to define the Fourier transform, you need to use a software. For this purpose, you can, for part A, when you define the Fourier transform for ft, you will find something like this. For example, it will be equal to, for example, I don't know, 100 times by, for example, sine times by 2 times by t plus, for example, 200 times by sine times by, for example, 3 times by t, and so on. Okay, so ft will be something like this when you use the Fourier transform. Okay, when you find this ft, this time instead of this 100, you need to substitute f, but before that you need to substitute time for your f. I mean, here first you need to substitute, we substitute t is equal to t naught at f, and then here instead of f you should substitute, for example, let's define a name for this, for example, ff, and then here instead of the 100 we substitute ff. Okay, this ff in fact is your external force, or your non-homogeneous term at t is equal to t naught, and at the end of this loop you are defining a new t naught for your next step. So the next step, when the loop is repeating, t naught is, for example, h. For the next one is 2 times by h. For the next one is 3 times by h. And you are calculating the ff for each step. I mean, the first step, for example, in the first loop, you are calculating for here when t is equal to h. For the next one, you will find the f for here when it's equal to 2 times by h, and so on. Okay, so my suggestion is to use the Fourier transform, or you can use also, of course, you can define this ft in the Maple by using the stepwise functions, but because this is 24 seconds and your period is 8, you need to define 3 different functions for this purpose. So it will be a little complicated. You need more lines to use in your program, but if you use your Fourier transform, you can directly import it from your part A. Clear?
Yes. No, so what happened was, like, usually when we use the formula and do working by hand, like for run scooter, you need height and like initial conditions. So that is where I went wrong.
The initial condition is the same. I mean, in this code, the initial condition is the same. You don't need to change anything. Only for the external term, for the non-homogeneous part, in this equation, I use 100. But in your assignment, instead of 100, you have a function of time. You have ft. Okay, so as I told you, only you need to substitute, instead of 100, you need to substitute this value for f. But because in your assignment, this is not a clear function of time, I mean, ft is not a clear function. This is a periodic function. And for each second, you cannot substitute in Maple this function, because this function is from 0, for example, to here, which is 4, is a linear function with a positive slope. After 4, it has a negative slope. Again, after 8, it has a positive. So you cannot define it in Maple easily. The best option is using the Fourier transform, because Fourier transform will give you a complete function of time ft, a clear function of time for ft for this periodic function, and then you can use this form in your here in your equation, your code. You can directly substitute this ft, as I told you. This is, for example, the form of your Fourier transform. By using this Fourier transform, you can only substitute time here, and then instead of 100, you can substitute this value. For each step, you need to substitute only this ff. Again, you can define this ff here for k2, and again, instead of 100, you can define ff. Okay, in each line you define this ff, and you can use the same name. No problem, you can use the same, and the procedure will be the same. I mean, here again for k3 you will have another ff, and again instead of 100 I have this function. Here I have 4. Okay, so this is the same, only of course here for k4, I think according to this loop, here when you want to calculate the k4, instead of here for k1 we have t naught, but for k2 you should substitute t half, which t half in fact is t naught plus h divided by 2. So here we, after that, we can define, for example, t half, which is equal to t naught plus h divided by 2, and here instead for k2, instead of t naught we will have t half. For k3 we have again t half, and here instead of t naught we have t naught plus h. Okay, according to this algorithm. Here you can see for k2 we have t half, for k3 we have t half, but for k4 we have t1, which t1 in fact is equal to t naught plus h, and t naught will be replaced here in each step. And if you substitute this code, again you can easily find the response for ft, but you need first to calculate this ft before that. Okay, because this ft must be defined. Let's, for example, we can solve this equation, run for this. We will have ft, so only substitute. Of course I did not define t naught, it's 0, so let's again do from the start. Of course it will be run faster because my laptop has some problem now, so it takes a long time to run this code. This is a very simple code and easily Maple will solve it, but my laptop, because I have 2 different Zoom sessions, my laptop is collapsing. It's due on Friday, but maybe I will extend another 2 days. Yes, for question 2, if you have any question, you can ask. Yes, question 2 is up to you. This is a system with 2 degrees of freedom. Of course, to plot the total response, maybe you need a software. You can use any software like Excel, I don't know any software. But for part A and B, you can find the response by using a software, or you can use it without any software. You can find the response as well.
So can you teach us an example using Maple, if you can?
Sorry? Yeah.
Sorry. So like for question 2, can you show us an example using Maple?
For question 2, you don't need Maple. I mean, when I talk about software, I mean, you can use Excel, because you need to plot here in part C, you need to plot the response. When you obtain the response, you can by hand calculation, you can find the response, but to plot it, you need to use a software such as Excel. I don't know any software you can use it. But to find the response for question 2, you need to use the modal analysis method. As I explained, find the modal matrix, find the principal coordinate system, and then find the response for different cases. For FD delta unit impulse. And for these cases, I think you can also use the Laplace transform method. Okay, clear? Oh, it's still running. I don't know why my system is playing up. Okay, as I told you, because my system has some problem, had some issues due to the Zoom sessions, and it is still converting. So it will be faster if you run this code on your system. Definitely it will be very fast. It's very fast and you will not have any problem, but the procedure is the same, and you can use this code. I will upload it on Moodle. And again, if you had any question, you can send me on Viber, or you can send me an email. Okay, any question? Is it clear? Any other question regarding to your assignment and your and for your final exam? It's on Friday. Again, just to remind you, it's from 8 a.m. to 1 p.m. because after 1, one of the students, I think, has another exam, so it will be finished at 1 p.m. Okay.
Sir, just one last thing.
Yes.
For final exam, last part it says design problem. Sir, can you elaborate more? Like what sort of question would that be?
In fact, it's not a design question. To be honest, it's a type of question that you need to consider the value for the stiffness, for the mass, and for damping a constant, and then you need to solve this question. Okay, I mean, this is for at the first step you need to consider some initial assumption and some initial value for your, for example, your spring for the stiffness and for your damper, for example, and then you need to extract the equation of motion and solve the equation of motion. It's similar to the previous part, only the initial value, it's up to you. I mean, for example, for the student number 1, for example, the initial value will be different. For the student number 2, the initial value will be different because each student choose the initial value him or herself. Okay, so it's the different for the design questions. It's not very complicated, no worry.
Okay, thank you, sir.
Okay, thank you all. So if you don't have any question, we can wrap up this session. And if you had any question, you can again send me a message.